I can see you're from all over the world, and that's very, very nice to see, from different time zones. So indeed, good morning, good afternoon, or good evening from whichever time zone you are from. And so my name is Chris Stewart, and I'm the training coordinator at the European Centre for Medium Range Weather Forecasts, or ECMWF. And I'm very excited to present this training on use of climate data and data on the atmosphere that's freely available, freely accessible to everyone worldwide through the Copernicus Programme. So the purpose of this training is to introduce this data, to show you how to access it, and also to show you where you can seek more help in processing this data, in handling this data for whichever application interests you. So what I'm going to do is, in this training, I'm going to present first a few slides to introduce these different types of data, and then it's going to become more hands-on, and we're going to get our hands on the data. So there was some homework before this training, and that homework was to log in to or to register with the climate and atmosphere data stores, and also to obtain an API key. So you may or may not have done that. If you have done that, then it helps because it means you have already some familiarity with the catalog. If you have not done that, you can just follow along. So what I'll do now is I'm going to share my slides, and I'm going to present the Copernicus Climate Change and Atmosphere Monitoring Services. So I hope you can see my presentation. I'll just put it into presentation mode. Okay, so you should be able to see it in presentation mode now. Okay, so as I mentioned, this training is going to focus on the free data, tools, and services provided by the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. I'll present each of these in the next slides. And after that, we'll have a live demonstration. So these are the links to register for the climate and atmosphere data stores. This is part of your homework. But again, if you haven't done this, then you can do this at a later stage, or you can just follow along. The training will use the free resources that are provided on the training pages of the climate and the Copernicus Climate and Atmosphere Services. And these are in the form of Jupyter notebooks. So they're available in 2 Jupyter books. So this is one of the Jupyter books, and this is the second. So I'm going to introduce some of these Jupyter resources. So now, but before we actually do the hands-on data practical, I'm just going to introduce you to these services. So I mentioned the Copernicus Climate Change Service and also the Copernicus Atmosphere Monitoring Service. So these are 2 services as part of the Copernicus Earth Observation Programme of the European Union. So this is a very ambitious Earth observation program, which includes a fleet of multiple satellite constellations to monitor the Earth's atmosphere, land, oceans, and also to provide monitoring of climate change, security, and the data provided by these satellites. And there's also an in situ component, and there's also a services component. And the services that are provided are free, and they make data freely available to users worldwide. And the European Centre for Medium Range Weather Forecasts is the entity entrusted with delivering the Copernicus Climate Change, or C3S for short, and the Copernicus Atmosphere Monitoring Service, or CAMS for short. So I now refer to them as C3S and CAMS. ECMWF also is providing some support to the Copernicus Emergency Management Service in the form of flood and fire early warning products. So now just going to introduce C3S. And here you see the URL of the C3S website, and there you can obtain more information. So C3S provides authoritative information about the past, present, and future climate. On this slide, you see the famous climate stripes. So basically what we do is we provide data that fully characterizes the climate from the past decades, and also to different possible futures, because obviously the future depends also on our choices. So we provide the climate data that best characterizes and best provides the best information about the past and the future climate according to different scenarios. And the actual data that we provide, so there's multiple different types of data, from observations, which includes satellite data. So a huge amount of this data, the observational data, comes from satellites, but there are also in situ measurements and also rescue data. So data in paper format that has been digitized. So we have a data rescue service providing information on all the different data rescue efforts. And then we take this observational data and we combine it with models. So models of the Earth system, and the observational data is assimilated into these models to provide a very good characterization of the past climate. So basically taking the observations, which may be sparse in space and time, and filling in the gaps with the models. So that's called reanalysis. And also we model the data into the future. And that can be in the form of, so through C3S, we provide model data in the form of seasonal forecasts. So provide estimates for the upcoming season, but also we broker data from climate projections, projecting possible future climates according to different scenarios into the future decades. So these are the different types of data we provide. Now, all of this data, from the past, present, or future, is in the form of essential climate variables. So the actual variables of this data are the climate variables as defined by the Global Climate Observing System, GCOS. And the different ECVs, essential climate variables, some of them can be monitored by satellite, shown in red. Some of them come from reanalysis as well, shown in yellow. And then there's also the ambition, in the future ambition, to be able to monitor other essential climate variables as well. So these are shown in cyan. So you can see that these essential climate variables characterize the climate, and they can be they can be of the atmosphere, the biosphere, the hydrosphere, the cryosphere, and they include variables such as temperature, water vapor, pressure, and so on, precipitation, and so on. So what I'm going to do in the next few slides, I'm just going to go through some of the key data sets that you can access for free from C3S. So I'm not going to dwell too much on the observations. I'm going to go straight to reanalysis, which basically combine the observations with the model to provide a very good characterization of the climate. So one of our flagship products in C3S is what we call the ERA 5. So this is the ECMWF reanalysis product. And this provides a very, very good characterization of the climate of the Earth from 1940, actually, until the present. And what you see in the figure at the top, so you see that this information is not just provided at one level of the atmosphere. This is fully three-dimensional, or four-dimensional even, because we have hourly data from 1940, so every hour time step. And we have not just information about the surface of the Earth, gridded data covering the whole Earth, but also multiple levels of the atmosphere. And these different levels of the atmosphere you see in this time series at the top. And this is for global monthly mean anomalies of temperature. And the interesting thing about this is that because we're taking the observations and we're filling in the gaps in space and time of the observations with the model data, and because it's gridded, it's a very, very good data set to do studies and analysis of the climate. And in this data set, you can even see some events that perturb the global average temperature in this case. In this case, we have 3 volcanic eruptions here that you can actually see in the data set. But of course, we don't just have the global average, we also have the data for every grid point. And in the bottom chart, you see a map of, for one time step, of surface air temperature anomaly with respect to climatology. So the ERA 5 reanalysis product is very heavily used in climate research. So it's very heavily cited in the IPCC reports. Another type of, just to mention, we also provide, so that's global reanalysis. You also provide regional reanalysis data sets at high resolution. Also seasonal forecast products. So these are forecast to, forecasts of the future season. And what C3S does is it provides a multi-component system. So from different providers, not just ECMWF, but also from different data providers. And then it provides the data in GRIB or NetCDF format, but also in graphical format. So in the form of maps, as you see here, showing different terciles. So the upper tercile and the lower tercile, basically, the above average possibility. The possibility of above average of a particular variable or below average of a particular variable compared to the climatology, and then also in the form of time series. So this data is freely available. And then finally, climate projections. So these are projecting the climate into future decades according to different scenarios. And C3S brokers the climate projections from CMIP5 and CMIP6, the coupled model into comparison project, but also, so these are global climate projections for future decades, but also regional climate projections at higher resolution for different regions, not just Europe, but also other regions, other Cortex regions, and you see in this screenshot below the various different regions. Finally, so C3S provides data, but also climate intelligence products. So if you want an analysis of the climate from this data, so there are climate bulletins, monthly bulletins, providing a summary of the previous month. Also, the European State of the Climate. So this is for Europe, but providing a summary of the climate of the previous year. Also, different climate indicators. And then annual global climate highlights. So this is available from C3S, from the website. And I could mention other things as well. So we have support for different sectors, sector-specific data and services. We also do training, and I'm going to demonstrate our training resources. And we have comprehensive user support as well. So if you have any questions, there's a place you can go. I'm now just going to provide a whistle-stop tour of the Copernicus Atmosphere Monitoring Service, so CAMS for short. So this is a service focusing on the atmosphere. So CAMS provides, again, consistent and quantity-controlled information related to the atmospheric composition, including air pollution, also health, solar energy, greenhouse gases, and climate forcing all over the world. So while C3S provides model data for the upcoming season and climate projections, CAMS also provides forecasts for the next coming days in atmospheric composition and in air quality, as well as providing data on the ozone layer, emissions and surface fluxes, solar radiation and climate forcing, and so on. So all this data, again, is freely available from the CAMS website, and we're going to explore the data after these slides. So just to explain how the workflow works. So in CAMS, the data is, the observational data can be acquired by satellites and in situ instruments. And then these are assimilated into models, which can then be used to provide global and regional forecasts, or also reanalysis data from the past, so filling in the gaps of the observations. And then finally, these are delivered to users for free, and the users so are many different, including many different entities. So often it can be users interested in downscaling these global and regional products with local scale data to provide services such as air quality apps, which you can access from your iPhone, from multiple devices over a particular city or local area. Also for different journalists and policymakers. So there's a huge array of different types of users further down the value chain who are interested in taking the CAMS data and providing value adding to their own end users. Just to give you an example of some of the products provided by CAMS. So for the global forecasting, here's some examples of dust aerosol and fire aerosol forecasts. So these can be provided for the next 5 days from the global forecasts. We also have European regional forecasts at high resolution. Also emissions. So those include emission inventories, global and regional emission inventories for greenhouse gases and many air pollutants, and also fire emissions. And here in the figure on the bottom right, you can see an incredible figure that was highly publicized. And this is the total wildfire emissions over Canada this year. This summer, and you can see that they're way above the norm. So it has been an incredibly unprecedented fire season in Canada this year. And again, we can explore the data later in the training. Also, there's an ozone service to monitor the ozone layer. And you can see in the chart below that the last few years have been have been uncharacteristically, let's use that word, uncharacteristically high for ozone. But you can also see the trend for, for the last few years. And if you go onto the CAMS website, you can see this data. These charts are updated in real time. And you can also explore the data in the catalog. Oops, sorry, I went too fast. Finally, in addition to data, CAMS also supports decision-making, so kind of policy-making level. For those who don't want to take the raw data and handle the GRIB and NetCDF data from scratch, they can. We provide also tools to facilitate the processing and interpretation of this data. So here is a tool where you can see where air pollution is coming from and its chemical composition, and you can design your emission scenario for different industries. It's available on the CAMS website. But I'm not going to go any further because I think now it would be good to start exploring the data. So I'm going to finish now this presentation. I'll stop sharing this presentation. And I'm going to share instead, I'm going to share my browser. So what I would do is I would leave the questions to the end. I'm sure there are already lots of questions based on those presentations, but I'd rather leave the Q&A session to the end. So what I'm now going to do is I'm going to start a kind of live demo showing you the C3S and CAMS websites and how to explore the data. So you should see here now on my screen the C3S website. And if you go to data here, the data icon, you see it at the top here. You click on data, then you get to the data catalog. And this is what I asked you to to register for. So it's a very quick registration. I think you just had to put your email address and your name, and that's pretty much it. So let me just log out just to show you how that works. So here you click on login register, okay, and I've already logged in here. So I just but if you haven't, then you need to register and put it in private. Or just a few, not very much information. Then you click on login, and then you're already in the catalog. So you can actually use the catalog without, you can browse the catalog without logging in, but it helps to log in because then you can actually download the data, and it's free. So it's free for anyone, from wherever you are. So then if we want to look at the catalog, the easiest thing is just click on search without putting any search terms in here. You can put in a keyword if you want, but if you just click on search, then, and if you click on data sets, okay, then you see just a list of all the data sets. And all of these data sets are free. You can click on each and you can, you can download the data. So to do that, let me just make sense of these data sets. So they're not, the order does not particularly make sense. So I would say the most important data set that we have is not the essential climate variables for water sector applications derived from climate projections. Okay, this is not the most used data. But if you scroll down, you can see lots and lots of different data sets from the climate projections to the seasonal forecast to reanalysis and observations. To make sense of them, you can use these filters. So you can filter by product type. So here, if you're only interested in reanalysis or in situ, whatever, you can select these this box here. Also by variable domain, spatial coverage, temporal coverage, sector, and so on. So what we'll do is we will have a look at just some of the data sets. So Sarah, this is a regional reanalysis. You can also use a keyword here. So if we're interested in the ERA 5 global reanalysis, we can put that in there, and you find all the ERA 5 data sets. So this data set here, the complete ERA 5 global atmospheric reanalysis, this contains the maps without the map without gaps of climate data for different essential climate variables going back to 1940 at an hourly sampling. So if you click on this data set, then you see a description of it and a list of all the different, a description of the data, the temporal coverage, the horizontal and vertical resolution, and so on. You should also see the variables. In this particular data set, you don't see a list of all the variables. And then if you go to download data, then here you can actually download the data, okay? So what we're going to do is we're going to go back, and we're going to, instead of selecting the complete ERA 5 global atmospheric reanalysis, we're going to select a kind of subset of that data. So let's go to, so the land, the ERA 5 land is slightly high resolution, is high resolution, and it's over land. We also have the hourly data on pressure levels. So that's on different levels of the atmosphere. We also have hourly data on single levels. So if you just want a single level, or you can also select the monthly average data on pressure levels or on single levels. So let's look at the monthly average data on single levels from 1940 to present. If we select that data set, then here we already narrow down a little bit our the data that we have available to us. And here you do see a list of all the variables. And if you go to the download form, the download data form, then here you can actually download the data. So you can select the, you have to select these different checkboxes. So for example, you may be interested in 2-meter temperature or sea surface temperature. Then you can select, particular years, or you can clear the form, or you can select all. Okay, so for the moment, let's just select last year, so 2022. Again, you can select all, you can just select 1 month. So let's select September. Here you can select the whole area, the whole globe, or just a subset region. And then you can select the format of the data. So by default, it's in GRIB, but you can also select to have it in NetCDF format. And then you just click on Submit Form, and then you can download the data. So at the moment, it's queued, but then very soon now, can you see the link is available? And if you just select the download link, then it downloads it to my download folder. And it's only 2.1 megabyte, this particular data. It's a very small data set. Obviously, if you select the entire data set, that wouldn't work because it's too big. And there's a limit to how much data you can download in one go. Another thing I want to show you is, so that's if you want to use the web form, okay, you can click on the different variables. But if you want to download, a large amount of data, you can also do it iteratively, and you can do it programmatically. So instead of having to keep repeating, keep going back to the form and selecting these different checkboxes, if you go here and select, instead of selecting Submit Form, if you go Show API Request, then here you have a block of Python code, okay? And this block of code you can copy into a Python script, and you can, and this is and this will enable you to download the data programmatically. So you can iterate through different variables or different years or different months, different times, and that works because you're connecting, you're running your script in Python that then talks to the data catalog through this API. Now, in order for that to work, you just have to obtain an API key, and the API key you can obtain once you've logged in to the catalog, and then you just have to click on that link which was in the slide that I presented, and it's a link to show your API key. And you just click on that link, and you get to a web page that literally displays your API key, and you can just copy and paste that into a script. And now I'm going to show you how that script works. Just before I finish, before I go before I finish on the Climate Data Store interface, I just want to show you that the Atmosphere Data Store interface is identical. So if you go to the CAMS website and you click on Data, and here if you click on Access the Atmosphere Data Store, okay, then you get to an almost identical interface. Just the colors are slightly different because this is the CAMS header, but the interface is the same. And again, if you click on datasets, you see a list of all the CAMS datasets. And this includes the global emission inventories, the reanalysis products, and also the forecast products. So a European air quality, we have the global atmospheric composition forecasts. We also have the European air quality forecasts. It's just slightly higher resolution, and this is again freely available. And again, if you click on these links, then you get to an overview page describing the data set and listing all the variables. And then if you go to the download data section, you can actually specify the data you want to download. And again, you can download that using the web interface. Just click on download, and it just downloads the data to your download folder. Or you can again go to the API request and copy and paste that into a script. So what I would like to show you now is the training pages of both the Copernicus Climate Change Service and the Atmosphere Monitoring Service, where you can obtain Jupyter notebooks with example workflows that show you exactly how you can download data using the API and how to process that data, to visualize it, do some analysis for different applications. So now, while we're on the subject, while we're on the CAMS catalog, we can start with CAMS. So if we go to the CAMS homepage, we just go back, and then if you click on Help and Support, and you scroll down to training, here you see a training landing page where you have access to many resources that show you how you can make best use of the data. So I'm going to focus on these Jupyter Notebook tutorials, but there's also other resources. So we have training events, we have material from past training events, massive open online courses. So these are all available for you to browse, free resources. So if we start with the Jupyter Notebooks, so this is a Jupyter book where we have all of our Jupyter Notebooks listed on the left-hand side here. So we have notebooks on data access, data visualization, data processing, and then we also have a link to the C3S notebooks. So, for example, the data visualization tutorials shows you how to create maps, animations, time series, and profile plots and zonal mean plots. Also some data processing tutorials showing how to calculate the European Air Quality Index, how to monitor, calculate the size of the ozone hole. So these are example workflows, and you can take them and you can modify them as you wish. So for example, if we click on this one, on how to create maps, so here's the actual Jupyter Notebook. And what I'm going to do is I'm going to run this in, so you can run this. So this is basically a Jupyter Notebook has scripts, has code blocks in Python, interspersed with text in Markdown. And you could install Python, install Jupyter and run these, or you can run these in these free cloud environments where you don't have to install anything. You don't have to even download the data into your computer. You can download it into these cloud environments. So I'm just going to show you one example of these. So if we click on open in Kaggle, you can even go to if you go to the same, you can even do this while I'm doing this demonstration, or you can just watch and then do this in your own time afterwards. If you click on one of these links, so I prefer Kaggle, so the middle one. If you click on that, then what you will find is it will take you into this virtual environment where you can run this notebook. Now, I think Kaggle automatically, if you're already registered with Kaggle, it logs you in automatically. But if you haven't registered, you just do a very easy. I think I can even log out and log back in again just to try to show you how this works. I'm not entirely sure how you log out, but if you haven't registered with Kaggle, then there's a very easy login button. Let me just see how I log out, just to show you how that works. I'm not sure how to log out of Kaggle, but okay, it doesn't matter. In any case, you can go into Kaggle, and then you can just run these different. You would also have to. Yeah, you have to ensure that the internet is on. So there's certain settings you need to apply. So you just have to log in, you turn on the internet, and then you can just click on the play icon, and you can just run the different, and it just runs these different cells. So the first thing we're doing here is we're installing the API. Okay, the CDS API. So we click on the play button to install the API. Then we import a number of different libraries. Now, these libraries are already installed in Kaggle, so you don't need to worry about installing anything. We just click on the play button again. And then here, all you need to do is you need to replace this with your actual API key. Now, your API could be, it looks something like this. And if you click on this link, if you have already registered with the ADS and you click on this link, then you will automatically see your API key. And all you have to do is just simply copy and paste it into here. So what I'm going to do is I'm going to unshare my screen just for a moment, because otherwise you'll see my password. So I'm just going to stop sharing when I put the password in. Just going to do that. And then I'm going to share my screen again. Now I've put in my password and I'll share my screen. Okay, so you should see my screen again. Of course, this is still the fake password. I put my password in, then I hit the play, and then again I put a fake password in. So basically, your password would look something like that. Then we can just run these different cells. So you just play each one in turn, just run each one in turn. And here, what we've done, this script here is just a copy and paste of the script I showed you in the catalog when you, I'll show you here, sorry, in the catalog, it's this script here, okay? When you click on hide or show API request, okay, you're just copying this script. So this is the script that describes this particular download request, including the variable, the data set. So in this case, the CAMS global atmospheric composition forecast, the variable, the date range, the time, the lead time hour. So it can be up to 5 days ahead. And then we just copy and paste it into here. Okay, so now if we play that, then it'll download the data. And here you see it's downloading the data. It's already downloaded it. Then we can run this to read the data into, oh no, sorry, here we're extracting the data. So we're unzipping it. And then here we, okay, we're just creating a variable with the path of the data. So this is the path of the data. So it's just in the local directory and it's just called data.netcdf. And here we then read the data into an X-array data set. So we create an X-array data set from this data. And this data set, you can see, so X-array is a very good library for working with multidimensional arrays, such as atmosphere data in netcdf format. And here you see the coordinates of the data. So it has longitude, latitude, and time. And in this case, we have 3 variables. So we have organic matter aerosol optical depth, dust aerosol optical depth, and I think this is total AOD, so total aerosol optical depth. Then here we can, here we're going to plot the data. In order to plot the data, first we decide which variable we want to plot. So in this case, we're going to plot the total AOD at 550 nanometers. Okay, so if you want to get more information about the actual variables, if you click on the icons here, it tells you, you know, the long name in organic matter aerosol optical depth at 550 nanometers. If you click on these here, it should show you the data. But then what we're going to do here is we're going to create, we're going to extract just one of the variables into a data array. So we've done that here, and now we have the data array, which includes just the total AOD. And then we can just plot that. Now this, oh, sorry, this is not, maybe I didn't run this cell. So I've run this cell, now I can run this one. And this just creates, so this is the simplest plotting command of X-array. So, which is just a thin wrapper on matplotlib. And what it does is it's just a sanity check. So it just creates a first plot. Here we can't make head or tail of this. So we can see that it is a map and we can see something here, but we can't see any details. So what we want to do is to create a customized map And we're going to do that with the matplotlib and cartopy libraries. But what you can do here is you can just, if you're not that familiar with matplotlib or cartopy or any of these libraries, you can just, you can take this script, you can take this Jupyter notebook and you can modify it exactly as you wish. So you can change, for example, the instead of downloading this particular data set, you can go here and you can change the date range, you can change the lead time. You know, this is just the analysis. It's just the first lead time of 0. But if you want to have a forecast, then you can, you know, this is the lead time hour. You can go up to 120 hours into the future, so 5 days into the future. And you can select the time, whether just 12 or 0 UTC. And you can change these, and you can download whichever data that interests you, and you can do that for free. You can do that in this you know, online without having to install Python or anything else. So here you can then create a slightly more custom chart. So here we can see it much better. So we can see the total AOD at 550 nanometers. Here we see the so we see also we can see the grid, we can see the scale, but maybe we don't like this color scale. Okay, so what this block of code does is it just shows you how to create a custom color scale. And this is recreating the one we use for CAMS products on the website. So again, we just run this cell, and then we just go back to our previous block of code to plot the figure. I've just removed all of the comments here, so you just see the lines of code, and we just replace the color scale. So here we've replaced the color map with our custom color map. Okay, and then you see the same map, but with the CAMS color scale. Okay, so it's a discrete scale, and here you can see the different concentrations of aerosol optical depth at 550 nanometers. And then what this Jupyter notebook does is it then goes on to show you how you can create subplots. So if you want to look at multiple variables, multiple maps side by side, this loops through different maps for different variables, and it shows you how you can compare them in one figure. And also the projection is different. So here we're looking at the northern hemisphere. Let's say we're interested in the northern hemisphere, and we can see here total AOD. Here we can see dust AOD, and here we can see organic matter AOD. Okay, so this Jupyter notebook, I just ran this Jupyter notebook without installing anything, just through the browser, using this, you know, Kaggle free Jupyter free Jupyter Jupyter Hub. So we have many such tutorials. We have many such tutorials for CAMS. So that was just the one showing you how to create a map, but we also have one showing you how to create animations. So here you see how to create different animations, different ways. And we also, we have these various different Jupyter Notebook tutorials. And then, of course, for C3S, we also have a set of tutorials. So we have, these are organized in a slightly different way. So we have them categorized by data type. So we have tutorials on using our reanalysis data sets. So here's a tutorial on how to create climatologies, analysis of heat waves. We have tutorials on observations. We'll have more of these in the future. We have tutorials on climate projections. So this is on climate projections, for example, CMIP6, we show you how to plot the scenarios of, plot the time series of, in this case, temperature. And this is for the entire time series of the CMIP6, several CMIP6 models, and this is actually an ensemble of models. So we have the spread here. I think this is the between the 10th and the 90th quartile range of a number of different models. And then in the future, according to different SSP, shared socioeconomic pathways. Then we have also, climate projections, regional climate projections, showing you how to, in this case, how to compare, how to calculate the delta method, comparing the past with the future. So how to basically looking at the difference in air temperature between the 2071 to 2100 climatology in the future to, that one subtracting the 1971 to 2000 climatology. So you can see see what the difference will be. Also, we have a number of tutorials on seasonal forecasts, how to calculate seasonal forecast anomalies, even though the seasonal forecast anomalies are actually available as a dedicated data set. We still show you how to calculate these. So, here you can see the processing steps involved in calculating the anomalies from, the climatology and subtracting the current time step to derive the anomalies. Then we also have a tutorial on seasonal forecast verification. We have tutorials on climate indices. Again, these will be populated in the future with more tutorials. So these are all, freely available. I really encourage you to play with them. You can run them in these different locations. So in Binder, I think is not working as well these days as it was before, but hopefully that still it still works. You can run it in Kaggle and Colab, or you can also install these if you just install Jupyter, Python, and the various different libraries. You can install Anaconda. Most packages come with that. Then you can also run these in your own system. So, and the beauty of this is that they're fully modifiable. So you can change the code, and you can change them to suit your own individual needs. So this, I will stop here. So as there are quite a few participants in this call, I made this more of a demonstration than hands-on training. So I don't know if you have been, looking at these, clicking on these links and playing with the notebooks also while I've been presenting. Probably not, because it's very difficult to watch and do at the same time. I mean, of course, we could have done that if we had a smaller kind of classroom setting where I could even go around the room and check to see who has problems and who's able to follow the steps. So because this is a webinar with many participants, this has been more in the form of a demonstration. But what I'll do now is I'll stop sharing my screen, and I can maybe open the floor to questions.
So, Chris, thank you very much for your presentation. It was very easy to see how you work and how you can manage all the systems and make the predictions. We have not so many questions, and most of the questions you were answering right after the question was made. So it was like you are reading the chat and see the questions. Just one, I think, I don't know about Python, but it's feasible to employ these Python scripts within the context of MicroPython. Do you know if it's feasible?
Are we talking about that? Okay, I don't know. The answer is I don't know. I don't know if we're talking about, is it Python Lite, which is like the kind of light version of Jupyter, which can be run in a in a browser. Yeah. I don't know if that's what the participant is talking about. I mean, I'm a user of Python. I'm not an expert on Python, so I don't know what I don't know the answer, to be honest. I could find out, and I can try.
No problem. And all attendees, you are also free to send Chris questions privately via email, and he will be very happy to answer all the individual questions. And I think that's it. I have really no more questions. I was interested to know about the climate projections, where we are used to hear talking about this 1.5 degrees, the goal, 1.5 degrees goal to the 2030 agenda. And I think your work is helping to know if we are going or not to reach this target. Can you give some examples for us, how Copernicus and your system is helping us to see if we are going to reach our target of 1.5 degrees or not?
Yeah, so that's a very good question. We have actually on the, let me just share my screen again, because we have a very good application, which is called the 1.5 degree app. And if we go to the Copernicus homepage, then I think you will find it here. So how close are we to reaching a global warming of 1.5 degrees? And what this does, if we explore the app in the seat, so if we click on explore the app, then it shows you, where we stand.
Okay.
And it's very nice because it basically shows you at any given moment, according to that current linear trend, when would we, if we continue in this trend, when would we reach 1.5 degrees? So as you can see, unfortunately, it's getting ever shorter, the date by which we will reach 1.5 degrees. So at the moment, it looks like December 2034. Of course, this depends on how we behave in the future, but according to the current linear trend, this seems to be the case. So this is an example of an application that has been created using data from C3S. So you can even see the code for this, and you can modify it, or you can just use it for your own analysis.
Okay. Thank you very much, and I'm really glad to see you and all the participants here. And since we have no more questions in the chat, I would like to end our training, and thank you very much again.
Great. Thanks very much, Rodrigo. And thanks everyone for participating.